In this presentation, we're going to talk about the S-frame solver diagnostic messages, in particular about message SE065, zero thickness. This video is part of a series of videos that focuses on solver diagnostic messages. If you're not familiar with this topic, we have a separate video with a proper introduction to the subject. We're going to study the model you see here, a wooden platform with steel beams. Let's see. Here's our model. Some of you may be already familiar from previous recordings, but just to let you know, I have assigned some steel sections to my beams. For materials, I have steel for the beams, timber for the platform. It has fixed supports to the wall. I also have some shell elements, triangular and quadrilateral. If we move to the loads window and display the loads, I can see I have 3 load cases, vertical, horizontal, and self-weight. So I have 200 kilonewtons at the tip of each beam. And for the other load case, in the X direction, 5 kilonewtons at the tip. So let's proceed and run a linear static analysis for the load cases I have. And the first thing I notice is several warnings. Once that is done, I can see a summary here in the solver saying warning SE065, uniform thickness is 0. So this message is pretty evident, meaning that the shell thickness I assigned is 0. This warning could produce other messages like the ones you see here. As we always suggest, we should try and address each message separately, starting from the first message, as this may solve other messages I'm getting. So if we go back into our model, I will need to assign a thickness in order to avoid this warning. Since the model didn't solve, I'm still in the loads window, there are different ways to update your thickness. One way will be in the geometry window. If we go to the quadrilateral or triangular element tool, we will need to specify a thickness. In this case, I would like to assign 100 millimeters thickness. And in the modify, I just select the modify thickness option. Then I can just click and drag over my model, over the shells to assign that thickness. Since my model also has triangular elements, I will need to do same process, but with the triangular element tool, and assign to those triangular elements. If we see the thickness right now, we can see 0. The other way will be to delete all these shell elements, quadrilateral and triangular, go to the panel element tool, and if we display the thickness of the panel, I can see 0. We can just change the thickness to modify only the panel and assign the thickness 100 and assign it to this panel. Of course, these shells will not be there, and once I assign the thickness, it will generate my quadrilateral and triangular elements with thickness equal 100. But there's an easier way to modify the thickness for all elements in the spreadsheet window. If I go to the spreadsheet window, then select the shell spreadsheet, in this sheet I will see all my quadrilateral and triangular elements. And I indeed see a thickness equal to 0. So if I just change the thickness for the first value, the first row, and then select my whole column, I can just click this check mark. So this value is repeated in the other cells. Now that I have assigned a thickness for each one of my 2D finite elements, I can proceed, go to Analyze, run a linear static analysis, and on this occasion, I can see it comes with a clean solution. And I can start checking the results of interest. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.